Do you ever walk into a store thinking that you're going to spend $50 on few products or groceries, but somehow the bill end up $200 or $300, and you just look at things that you bought, something like gadgets and random things, snacks that you never planned initially. So that's basically what we talk about market basket analysis. Now, this session is going to be our 12th session, and in this session, we're going to talk about market basket analysis. Now, market basket analysis is basically an approach that helps businesses to organize their catalogs or organize their stores in such a way that a buyer spend more money. In this lecture, we're going to understand the mathematics behind it, how to apply it using Python and all that. Now, what market MBA is basically a data mining technique used to discover association between items that frequently occur together in the transaction. So what we're going to do is we are going to identify the items that most likely get sold together. And when we have these items, what we are just going to place them together in our stores, and they will increase the sale on auto. It is applicable in retail, e-commerce, healthcare, web analytics, and different kind of things where we have a similar kind of situation. What we're going to do is we're going to create some rules that basically helps us that if, for example, if someone is buying a bread and butter, there is high likely chances that he is also going to buy milk as well. Okay. So now this rule helps us to organize our store in such a way that where in particular session we have bread and butter, we should also have milk, because user is going to buy that as well based on probability. There are three key concepts in this MBA. The first one is sport. Sport basically means how likely an item is going to be sold. So the whole analysis that we're going to do here is based on the transaction data set. So if we have a store and we will just take its transactions data set and we create the model based on that. Now, sport is like how likely a particular item, like for example, if you're talking about the milk, is in the overall transactions. Okay, so transactions containing A basically means transaction containing milk divided by total transactions. The second key concept is confidence. Now, it measures how often an item B appears in the transaction that contains A. So basically, it's a confidence, and it tells us that we are talking about the B here, that what are the chances that B is going to appear if we have item A in our transaction history. So basically we calculate the sport of A union B, sport with this particular formula, like where we are going to see that how many times they often appear together divided by total transaction, and we divide it by the sport of A. Okay, and this basically gives us about the confidence, and from that confidence we move on to the lift. Lift is again based on that particular formula confidence, but we divide it with the sport of B. Okay, now what confidence tells us, like how often the item in B appear in transaction that contains A. But when we divide it with the sport of B, basically we are trying to say that this particular, we have confidence that this particular item is getting sold with A, and we know that how much B gets sold on its own. Okay, like sport of B basically tells us how much B exists in the total transactions, right? So this is mathematics behind a priori market basket analysis, and we are not going to calculate this based on the formulas. We are just going to use predefined functions. If we have a lift is equal to 1, it basically means there is no association between A and B. If it's greater than 1, it means these two items should be together and we have association, they are getting bought together. But if it's less than 1, it means they are unlikely to be bought together and we should not place them together in our store. We are going to use a package MLXTEND here that basically have all the formulas and all that stuff for a priori. Again, this is the same style of code. We are importing pandas, numpy, matplotlib for visualization, seaborn for visualization, but there are two new lines and these contains frequent patterns. So basically we're importing two different functions from here, a priori and association rule, and we will use it in later in this session. The another thing is transaction encoder. So basically we talked about one hot encoding and label encoding. It is a kind of one hot encoding. We will see how it works. Now for this particular problem we are using a dataset, and that's how our dataset looks like. We have a member ID, so if someone appear in a market buy some things, it get a member ID and it will list the items that he purchased. The first person that appear on 21/7/2015 bought candy and tropical fruits. Okay, and we are going to utilize this dataset for our analysis. We are loading it since we are in Google Colab, so if you haven't uploaded your dataset here, it is not going to work. So you first must upload your dataset here. Now there are 30,000 rows in our dataset and 3 columns. We already seen 3 columns. What we are dealing with here, we have a member ID, date, and the item description. Now this is some basic stuff. We already know how we treat the dataset initially when we load it in Python. Like we see the different data types here, see the missing values here, do a little bit of data exploration. So basically this is something that we have already done, and I'm not going in depth with this. But here if we know the function value count, that basically helps us to identify that how much time a particular category appear in our dataset. For example, in the case of this dataset, if we are trying to say item description dot value count, basically means we are going to see the count for each category, like how many time candy appear in our dataset, how many time tropical fruit appears in our dataset, and that's exactly what we are doing here, and we are using it with the head command. So basically we get top 20 products that get sold, and here we have it like whole milk, vegetables, rolls and buns, soda, and all that. Now we start with a simple bar plot, basically that to helps us to see the top 20 categories that we just found out. And now let's move on to okay. Now when we are talking about the a priori market basket analysis, we need a certain type of data set. Okay, we cannot just, it has its own processing. Like we do data pre-processing, right? We normalize the data set, we sometimes standardize it, we impute missing values, we do all that stuff. But for a priori we have a certain standard that we must need to follow. Our data set should look something like this. So we have lists of transaction. So transaction 1 contain these items, transaction 2 contain these items, and all that. Okay, so whenever we're using a priori, we're going to deal with the lists, and for each transaction we have all the items in a single list. Now how we are going to transform our data set here, we have only 3 columns and we have each product separately, right? What we're going to do is we are going to create a transaction ID column, and for transaction ID what we are saying is we are going to use member number and the date. So basically we're combining these two and we are placing a underscore here to create a new column based on that. Okay, and also we are treating both of these as a string. So basically they are words, categories. We don't need their numerical significance. Once we have a transaction ID, what basically we have is we have a unique identifier in our dataset, right? For example, if I go back to our dataset, before these steps, I have to see 2 things here to identify that this is a single transaction. One, the member ID. Okay, for example, this is the same member, but if the date is not the same, it means these are 2 different transactions at 2 different days, right? So what we did is we combined these 2 columns into a single column and created a unique identifier that tells us that these particular items belongs to a single transaction on the same day. And once we have that, we can just use that new column to group by. Basically means to see categories in a single transaction ID. Like for example, if these two belongs to single transaction ID, we did a group by based on that. What we're going to see is we're going to see these two entries here. That's exactly what we are doing here. We are grouping by our dataset. dfraw is basically the name of our dataset with transaction ID, and this transaction ID leads us to item descriptions. Item description is the name of the column that we are talking about that contains items. Okay. And again, we are using it as a list. We are applying list on it, and we are using dot values here. Now the point of using dot values is when we apply list here, we get two things. We get index, we get the values, this particular list, right? And we don't want the index here. We need a clean data set that only contains our list. Okay, index basically means list 1, list 2, list 3. We don't want that in our data set. So that's why we just select from here, we select dot values, and again we convert the values into the list. So that's the type of dataset that we need. Now this is not the exact type of dataset. We are moving toward the data that we need. If we want to see it, that dataset looks something like this. For each transaction, we have a clean list here. Now we are going to transform it with the transaction encoder. Transaction encoder is basically something similar to one hot encoding that we discussed in lecture 2 or lecture 3. Basically what we are going to do is we are going to list all the categories, list all the products into columns. Okay, and we create columns based on that. So for example, if we have 100 different products, we will have 100 different columns. And for first transaction or for first row, we will have one value on sausage, whole milks, semi-finished bread, yogurt, and all the other values are going to be 0. So that's basically what one hot encoding do, or something like that. It's in the true and false state or in the 0 and 1 state, both works. Again, this is going to be a simple process. We just imported a function transaction encoder and we fit it on our dataset, transactions dataset. Transactions is basically name of the dataset that we just created. Just make sure to use transform after fitting it. So basically we transform our dataset into proper transaction format. And after doing that, we just create this big matrix into a data frame, a pandas data frame, and now the whole process we are going to use df encoded. Basically is the name of our new dataset that is basically supported by our package for Apriori algorithm. Now we created this plot before, right? And now we are going to create this plot again. And these two look similar, but these two are different plots. Here we are seeing atoms appeared, right? And here we are seeing atoms appeared in transactions. For example, if we have two soda in the same transaction, these are not going to be counted here because we are talking about the transaction frequency. The code is going to be similar. We have some static things like title, label, and all that, and we have a one line for setting the dimensions like 14 by 7 to get a 14 wide and 7 lengthwise image. And here we are also using sum. So basically we have this particular data set, we are taking the sum of it to get the actual categories, to get the actual number, like how many times sugars appears in each transaction, how many times sweet spreads appears in each transaction. We sort them, so basically we get the top 20 values and we save it in the atom frequency, and based on that we create this plot for top 20 products. Now if we talk about the logic in the bar graph plot, we are saying that we are using color is equal to coral, so basically for this orange tone. And if we are looking at the range, length, atom frequency, so basically we are specifying it that there are 20 categories and these are the values for each category. And again, since we use 20 categories, so there are going to be 1, 2 and numbers here, not the actual name. So that's why we are using ytix is equal to range. So these 20 should be the index of their item frequency. Index basically means the row name, and row names here belong to their actual names here. After that, we just apply the Apriori algorithm. Now, this is the whole code to run the Apriori algorithm. Like, we use Apriori, we provide it the name of the data set, we provide the minimum support. Okay, now minimum support is something that we can tweak. Okay, for example, minimum support basically tells us that at least this percent of transaction appear, so it should be at least appeared for, like in that particular case, 0.5% of the times in our transaction. Okay, and here max length is equal to 3 basically means that we're talking about 3 combinations. Like either there's a single atom that's pairing more, either two appear in two atoms appear together, or cells together, or 3. We don't want to go beyond that. Now, so if we have a very large data set and there are so many atoms that get sold together, we will have a lot of transactions with 0.5%. But in that particular case, in that particular data set, our data set is small and we don't have much of transactions. Like if we go back, we have total 14,000 transactions here. Okay, now if we are talking about Walmart or some big store, so these transactions basically may be related to 1 or 2 days of sale. Okay, so that's why this is not going to be significant for significant results to rely on. Now, if we have a large data set, we have a lot of atoms appearing together, we will adjust it. Like if we run you run this code, and you will see that you are getting 1,000 different rules, or 100 different rules, or 50 different rules. Like for example, in this particular case, we used a priori and we are getting we are getting 126 different frequent atoms. If we want to reduce that, we can increase the number, and if we want to increase that, we can decrease this particular support values to get the more rules. We train a priori, it gives us frequent atoms, and based on that, what we are going to do is we are going to use atom size counts. So basically is again value count formula to calculate the number of time it appears in our frequent atom dataset. Okay, and if we go to the output, here we can see that we are using 0.05. This is basically a print statement that's added in our code. This one, total frequent atoms are 126. How we can achieve that, basically just take the length of frequent atoms and we get that how many times they appear. Now in frequent atoms, we specify that max length is equal to 3. So basically we are going to get combination of 1, 2 and 3 different atoms. Now we have frequent atoms, and they have like different atoms, like group of 1, 2 and 3. And what we're going to do is we're going to first identify that how many groups we have and how many atoms that we have in them. To do so, what we did is we just used length of frequent atoms. Frequent atoms are basically a set that we get from a priori, and its length is 126. So we have 126 different groups, and now we're going to see that how many particular items we have in these groups. What we're going to do is we are going to use frequent atom, and it has a column name atom set, and based on that we will use value counts to get number of values in 1, 2 and 3, and based on that we have values 89 atom sets that are individual, like we have only one pair, and there are two pairs or two group of atoms, and we have 37 different rows for that infrequent atoms. Now, since our data set is very small, like for example, when we are talking about transactions data, we work on a lot of data set. Like when you're working on something like this, you are most probably going to work with multiple GBs of data, not MBs of data. Okay, gigabytes. Now we know that. Now let's explore them, and to explore that, what we are going to do is we are going to explore first 20 sets. Again, we are going to use sort values column for that, and we're using it with the head command to get first 20, and ascending order is equal to false, so we get the highest value at the top. Now whole milk has the highest support. It means whole milks get sold a lot, and following with vegetables, rolls and buns and soda. Now these are the individual support values, so we know that these items get sold a lot in our store. Now we are going to explore the two-dimensional atom sets, so basically we can understand what atoms get sold together. Now this is just a plot to see this thing that we just said, 89, 37. Again, same code, same coding, same plot style and all that. Now let's explore the pairs in our atom sets. Now let's talk about the code first. Now in the code, what we are going to do is we are going to use frequent atoms that we generated from Apriori, and based on that we just defined a condition that atom set should be greater than 1. So basically we are talking about the atom set 2. Okay, and this is the code for condition. I use lambda here to understand that we can also go with this as well if we want to. Now what we did is frequent atoms. In frequent atoms we're talking about atom sets, and we apply lambda function that length of x should be greater than 1. So in atom set the length should be more than 1. So basically we have 2 or 3 different atoms, but in that particular case we have 2, so that's why we're going to get only 2. Now once we run that, we will get this particular table that shows us support. Now why we are trying to see support? Basically we are trying to see that how much data we have where we are getting bottled beer and whole milk together. Okay, and now after that we're going to talk about the main thing, that's lift. Now what we did is we just give it a name for 2 atom sets, and we give it a name multi-atom sets, and we talked about that first top 10 multi-atom sets, and based on that we created our table, this one. Now let's talk about the rules. And now if we already applied the Apriori function, okay, Apriori do the modeling, and we get the lift by using association rule. Okay, so after applying the Apriori, we apply association rule over our frequent atom that we get from Apriori, and based on that we get our rules that tells us like how atoms get sold together. Now here we reduce the confidence threshold. The more we reduce it, the more atoms we get. Like before reducing it, we are getting 37 rows. We reduced it a lot, we reduced it to 0.01 to get 74 rules. Okay, and now these are our things. Now this is a kind of if and then statement, like if someone is going to buy this, he is most probably going to buy this, and this is the lift value. Okay, lift value basically should be 1 greater than 1 if we say they have association. If it's 0, we say there is no association, and if it's less than 1, it means there is negative association, like we should not supposed to place them together, because if someone is buying one, he is not going to buy other. Now let's talk about the confidence. Confidence basically means we are 30%, 13% confidence about that particular rule, in that particular case. Now, based on that, if someone is buying Frankfurter, he is going to buy vegetables as well. So we have to place them together. Okay. And if someone is buying yogurt, he is going to buy sausage as well. So these should be together, and we're getting more than one because they are in pairs. And if someone has if and then relationship, so it's reversible. That's why we're getting both of them. We can clean that with the cleaning, little bit of cleaning them, but still we're ignoring it right now. And now if we go back, go at the end, we are getting like values like 0.85. That is basically below 1. And this means these two atoms should not be together. Like whole milk is not going to get sold with the pork. If someone is buying pork, he is going to ignore the milk. So we should not place them together. In the same manner, we get the rules that basically helps us to identify the pairs that have relationship. Now, since we are dealing with a very small data set that's basically of some megabytes, we are not getting that much of rules. But when we are working on a real world problem, a real world data set from real world store, we are going to deal with the gigabytes of data, and we will have rules for 2, 3, or 4 different atoms as well. Now, after that, what we did is we just created a plot for that to see the exact same table in the visualization. Now, why do we create plot when we can just read everything from here? Basically, visualization helps to understand the mathematics without technicalities. Like if you're trying to explain something to some non-technical person, or you're working in a company and you have to explain your results to shareholders, you're not going to say that this is the lift and this is that. You're just going to go with some visualizations that will explain that how things work together. So that's why we try to plot every result that we do. Again, this is the kind of same thing, not much different from previous. Here we are using unnecessary if conditions, so if you don't want to do that, you don't have to do that. This is much simpler. This is just a complex way of coding it. Now this code block is not much useful in this particular case, but this helps us to identify that how much strong association we are getting right now. Since in that particular case we only have a one significant rule, that's why we're getting only one rule here, and that when a customer buy frankfurters, they are 1.1x more likely to also buy other vegetables as well. Now this is based on our data set, but when we're working on a big data set, we will see a lot of rules here. Here we just use some if statements, if else and for loops to basically we just give it random threshold, and based on that we said if it lies in that particular region, we are going to say it's strong, it's very strong, it's moderate and weak. Now if we want to see that how many transaction we have where we have different combination, we can see it in the heat map that we just created. Like for example, if we say this particular block, whole milk and bottle beer appear 107 times together in the transactions. In the same manner, if we talk about something like canned beer and bottle beer, they appear 22% in the transactions. Now, whole milk and other vegetable has the highest number of 222 transactions, and based on that, we are also seeing that we have a strong lift in them as well. Now, let's talk about this code. So basically, we have DF encoded data set that contains our frequent atoms, right? And no, I think no, it basically contains the whole dataset that we pre-processed for our Apriori algorithm. Okay, and from the whole dataset we take the sum. So basically, if we go back, what we are talking about is the big matrix with true and false. This one, we are taking the whole dataset. We are taking the sum of each column. Basically, we're taking the column-wise sum. So how many time food products pair, how many time artificial sweetener pairs, and all that. We are taking some of them and we are taking the largest 15. So the one that has the highest values, we are taking the top 15, and based on that we are going to list them, convert them to the list. Basically we're talking about their index, and we are just, now this is a condition that we just defined to get the index of the top 15 from all the atoms. We just implement this condition on our data set. Df encoded is the whole data set, we want only this condition, so basically we will get the top 15 atoms. Okay, and once we have them, we will convert it into integers. So basically we don't have true and false, instead of that we have 0 and 1 value. Now in that particular case, we take the data with 0 and 1 values for top 15 atoms. So we transpose it, basically means we converted rows into columns and columns into rows, and take a matrix multiplication. It will going to give us a 15 by 15 matrix that basically show the co-occurrence of the atoms. After that we will just convert it to the float type, and we will fill the NA value in the diagonal, and basically we are trying to create this particular matrix. We are trying to fill these NA values to get a clean heat map, and we visualize that. Again, we use the dimension for the figure size. We used a heat map function that basically helps us to create the heat map. Now in heat map we give it the data set that we just created after doing the transpose and multiplication, and based on that we give it title, labels, and all that. After that we just calculate the statistics with for loop. Basically we're trying to see a cleaner version of this table in a table like this, and we are doing it with the dataset that we just created, and that's why we are going to use for loop that will just go through each of them and match them with the other atoms. So that's it for the a priori. Now if we are just trying to say what we have done in this session, we just studied a algorithm that helps us in market basket analysis. Okay, so basically it deals with transaction data set where we have multiple transactions and we want to see that how things work together, and it helps us to arrange e-commerce stores, to arrange different kind of stores and all that. Whenever we have some kind of products and transactions related data set, we can use this particular algorithm. So that's it for this session. See you in the next session.